All right, so remember 5.3, we're talking about essentially area between two functions, and sometimes we can specifically be asking for the area between a function and the x-axis, and those are usually phrased in terms of the words total area. And so we did one example, we got to one example down here, which was the total area for x cubed. So let me just remind us of this process, and I didn't quite finish this exactly because we were running out of time, so I'll finish the answer. So remember, we essentially have three steps, if you will. We have to find where they intersect. We essentially have to find where we need to split up the interval. And then we need to find which function is on top of the other. So the reason we have to find where they intersect is that sometimes these can flip-flop. And remember, from the beginning of these notes, we found that any area that ends up below the x-axis actually ends up being negative. And if we want to know the total area, which is technically how much stuff, we need to count that negative piece as positive. So that's kind of why we need to break it up, because any pieces that end up below the x-axis need to somehow be treated as positive. And that's essentially why in this case, in this example here, that kind of leftmost piece, the one that was between -1 and 0, that's why the integral that we ended up with for that piece ended up being 0 minus x cubed, because essentially integrating negative x cubed is going to treat that essentially as positive now. So that's kind of why we have to do that. But we found where they intersected. We split up the interval into two pieces. We found which function was on top of the other. Remember, there's two ways to do that, either graphically or algebraically. Algebraically is very similar to that test point idea from first derivative number lines, and then the graph way, you just stare at it. So we set up those two integrals. Also remember, at this point in terms of these types of questions, if you have a calculator that can do integrals, you can go ahead and punch that in your calculator. If you don't have one, then unfortunately you have to do it by hand, but we do know how to do them by hand. So let me just finish out this answer really quick. So if you had to do this by hand, your antiderivatives would be -1/4 x to the 4th. I'm going to not write my plus c just to save myself space, but they always cancel out with the ones with the bounds anyway, so it'll be all right. And then +1/4 x to the 4th from 0 to 1. So remember, when you do those by hand, you plug in the top bound, and you subtract what you get when you plug in the bottom bound, plus, and then our sorry, my English isn't working right now. Essentially the second integral. I'm always going to mix those two up in this section. It's the worst. And subtract what you get when you plug in the bottom bound. Essentially 4th plus 1/4. So the final answer here ends up being 1/2. So essentially, if you typed both of those into your calculator, you should get 1/4 for each separate integral. And then, of course, you add them together to get a total answer of 1/2. So essentially, the other day we looked at, I'll scroll back down in a second, but we looked at the generic integral over -1 to 1, which turned out to be 0. So in terms of a generic integral, it ends up being 0, but if we wanted to know how much actual stuff was there, it ends up being 1/2 whatever units we're working with squared. Okay, so that's the end of that one that we didn't quite finish up the other day. The other thing we just slightly passed by was this formal statement of kind of the process that we're doing here. So the formal statement kind of up here. So let's touch on that really quick before we do pretty much examples until the end of class. So formally, what we're saying here is that if f and g are continuous functions, and let's say that g of x is less than f of x, which is essentially going to mean that g of x is our bottom function and f of x is our top function. So g of x is less than f of x on some interval, then the area between the graphs of f and g on that interval is equal to the integral from a to b of f of x minus g of x. So that's more of the formal statement, but it's essentially exactly what we've been doing, but just stated super formally. So now we're going to do examples for the rest of our time. You're fine. I was kind of wondering what that was for, but I figured it was just a accidental typo. All right. So I'll leave that up really quick before I scroll down for like 5 more seconds. But what we're going to look at now is we're going to look at finding the total area underneath of x cubed minus 7x squared plus 11x on the interval 0 to 4. So we're going to do the same type of process that we did in example 3 the other day. Oh, Kayla, yeah, the study guide for your exam, that got up late last night. So that's up on, it should be up on Blackboard. Let me triple check. But yeah, I put that up last night. The answers aren't there yet. They will be there when I can get them there. Yeah, the review packet is up on Blackboard. And I'll get the answers up when I can. The answers should be up sometime this weekend. I don't know exactly when, but they'll be up by Monday. So those will be up when I can get them done. All right, so let's look at this guy. So the first thing we have to do is we have to find where the two functions intersect. Now here, the statement of the problem doesn't quite have a second function in it explicitly. But remember, when we're working with the total area questions, that means that our second function is y equals 0. So if the first thing we need to do is find where these two functions intersect, we have to set x cubed minus 7x squared plus 11x equal to 0. So the first thing we can do here is that all of those terms have an x in it, so we can pull the x out of it. So we'll get x times the quantity x squared minus 7x plus 11 equals 0. So essentially either x equals 0 or that quadratic equals 0. Now, let me box this before we forget about it. That means that x equals 0, and now we need to figure out what the other two give us. Now, unfortunately, that's not factorable because there doesn't exist two numbers that multiply to 11 and add to -7. So we will have to use the quadratic formula on this. So if we use our quadratic formula, we'll have negative b, so negative 7 gives us positive 7, plus or minus the square root of b squared minus 4 times a times c. So I said the letters but wrote the numbers, all over 2a. If anyone wants to see any of the algebra on that, let me know and I can do the algebra out fully. But if you do the algebra on that, you'll get 4.618 and 2.382. So those are the two numbers that we get from using the quadratic formula. Again, if anyone wants to see the algebra, let me know. Now at this point, we would want to be splitting the interval. I'm gonna unfortunately always mess up which word I want to actually use. So Kayla, that's not factorable, because if I wanted to factor that, I would have to find two numbers that multiply to 11 but add to -7. The only numbers that multiply to 11 are 1 and 11, and there's no way for me to add or subtract 1 and 11 to get 7. So since I can't factor that, I have to use the quadratic formula. There's no other way to solve it. Well, unless you like graphed it in your calculator and use your calculator. But since it's not factorable, we're forced to use the quadratic formula. So at this point, we'd want to split up our interval. Now our interval that we're given is 0 to 4. So the three numbers that we found when we set these two equations equal to each other were 0, 2.382, and 4.618. The 4 from the... So if we do the algebra on this guy, -7 squared is 49, and then 4 times 1 times 11 is 44. So this will give us 7 plus or minus the square root of 5. Now the square root of 5 is not a nice number, so we're going to say that that's approximately 2.24. So watch my decimals not give me the same decimal I got in my answers because I rounded too soon. The next thing I'll do will answer that. So doing the algebra on this quadratic formula, notice the plus minus in the middle. That's what gets us the 2 answers. So we essentially have to split this up into 2 calculations now, where we add in one case and subtract in the other. So 7 plus 2.24 divided by 2 gives us 4.62. So why don't I go ahead and change that to 4.62 then? And then 7 minus 2.24 divided by 2 is 2.38. So yeah, I rounded differently than I did in my notes. But yeah, that's why the quadratic formula always, well, most of the time will get you 2 answers. Sometimes it can get you 1, but that only happens if this thing inside the square root was 0. But yeah, we have to split it up twice. Does that answer your question, Kayla? I was kind of confused by your phrasing, but maybe that's what you were concerned about. But I'm not sure. So let me know if that didn't answer your question. But that's the algebra for how those 2 numbers came into being. So I'll leave that up for a couple more seconds in case someone's maybe writing it down. Oh, okay. That's just literally the quadratic formula. It's 4ac all over 2a. So the 4 just comes from the quadratic formula, which is something you unfortunately just have to know in your brain. Scroll up, sure, for a couple seconds. You mean just like this thing that we didn't get the other thing? Was that enough up? I'll wait there for a couple seconds. Okay, hopefully that means you're good. So let's go back down. Okay, so now I gotta erase all this so that I have space to do the rest of the problem. do. So, what was I saying? So we're working over our interval 0 to 4. Now notice that the one value we got from the quadratic formula is not in that interval. So the 4.62 we're not going to use because it's outside of the interval that we're working over. So kind of just like with the global max and min stuff, if you ever find a value that's outside of your interval, you just don't care about it. So we're not going to care about that 4.62, but we are going to care about the 2.38. Now the x equals 0, we kind of do care about, but it's already an endpoint, so we don't really need to do anything with it. But essentially, when we think about splitting this, so we're going to end up with 2 integrals. One of them is going to be from 0 to 2.38. So I know that's going to be a little gross, but we'll deal with it. And then from 2.38 to 4. So now we essentially need to figure out what needs to go in those boxes. So let me try to block some things off so I have enough space. Here, I'll do a graph there. I'll do that there. There we go. So now that we know what 2 essentially integrals we need to calculate bound-wise, we need to figure out which function is on top of the other. So remember, there's 2 ways to do this. I'm going to do both of them again. You don't have to do both. It's one or the other, whichever floats your boat. But I'll do them both just for the sake of practice. So if you're doing the algebraic way, you consider your 2 intervals that you're going over. So we're going from 0 to 2.38 and from 2.38 to 4. You pick a number, any number you want that's in that interval. So let me pick, I don't know, 1 and 3. And then you take that number that you chose and plug it into both functions that you're working with. So we're working with y equals 0. If I plug 1 into y equals 0, there's nowhere to plug in x. I just get 0. And if I plug it in, now I don't have space to write the full function out, but if I plug it into the x cubed thing that we're working on, if I plug in 1, I'm going to get 5. Which one of those 2 numbers is larger? 5. So that means that the x cubed function is going to be on top for that first interval. And then if I plug in 3 to both of these functions, so if I plug in 3 to y equals 0, again, I just will get 0. If I plug it into the x cubed function, so the x cubed minus 7x squared, I just don't have enough space to write out the full function. I'm going to get -3. Which one of those 2 numbers is larger? 0. So y equals 0 is going to be the top function in the second interval. Now, I also want to clarify, don't assume that it's always going to change. A large amount of the time it will, but sometimes it actually won't. So don't assume that just because the x cubed thing was the top in the, left interval, that it's not going to be the top in the right interval. You always need to triple check. The other way you can do it, again, one or the other, keeps glitching. Well, that's not good. Let me unshare and see if that helps a little bit. But if at any point, like, I'm going too fast and it hasn't caught up yet, just, let me know. Because it's working okay for me, so if it's not working for you, you need to let me know. But you just did. Anyway. So the other way we can do it is we can look at the graph, which looks something like this. And essentially, so this is going to be the 4.6 number, and this is going to be the 2.38. So 4 is going to, block us off right there. So that's where we're going to stop our interval. And now we're comparing that function with the x-axis. So which one's on top? Well, in this kind of first piece, the function ends up on top, which is exactly what we found out algebraically. But then in the second piece, the x-axis ends up on top, which again is exactly what we found out algebraically, because again, you don't have to do both, it's one or the other. I mean, if you want to do both to triple check yourself, that's perfectly fine. Whatever floats your boat. So at this point, we're now ready to finally set up, that doesn't look like a 2, our integrals. So in that first integral from 0 to 2.38, we found that the x cubed function was on top. So if we do top minus bottom, it's going to be x cubed minus 7x squared plus 11x minus 0, because our bottom function is y equals 0. Now, again, I think I already mentioned, writing the minus 0 I know seems a little silly. If you want to drop it, that's fine. But be really careful if 0 is the top function, because writing 0 minus something definitely changes it, because you'd have to distribute a negative. But if you want to drop the minus 0 at a back of a function, that's perfectly fine. And then in the second interval, y equals 0 turned out to be on top, so we'd have 0 minus the bottom function. Now here we would need parentheses. And if you just want to put your bottom function in parentheses always, just to, be a little safe, that's perfectly fine. But here, since the bottom function has more than one term, we would need to distribute the negative if we were doing this by hand. So be really careful about that. You could, of course, do these by hand. The antiderivatives, I'll write out the antiderivatives, would be 1/4 x to the 4th minus 7/3 x cubed plus 11/2 x squared. I'm dropping my c's again just for the sake of space, because I'm running out of space. And then negative 1/4 x to the 4th plus 7/3 x cubed minus 11/2 x squared, from the 2 thing to 4. I know it's 2-point thing, but I ran out of space. But again, if you have one that can do so, you can just punch both of those integrals into your calculator and call it a day. Now, in terms of that bound being 2.38, on your exam, the numbers for your bounds are going to end up being nice. And now I have to make sure that I write questions that end up being nice. But x cubed equals, well, hopefully it's what it's supposed to be. Let me triple check. Yeah, so I essentially took the x equals 1 that I chose for that interval, and I plugged it into the function, so I'd have 1 cubed minus 7 times 1 squared plus 11 times 1, and that gave me 5. And that's also how okay, Kayla, I was running out of space, so I'm not saying that x cubed is 5, I'm saying that the x cubed function gave me 5, hence the ... So I know that notation is horrendous. Let me try to squeeze it in there, because you're right, if someone looks at that later, they're going to get very confused. 7x squared plus 11x, that gives us 5. And then that one ended up being on top. And maybe if I write it there, they'll get it for the other one. But anyway, yeah, sorry, I didn't just plug it into x cubed, plugged it into the whole function. And so the answer for this would be 12.77. Any questions on that one? Any more questions on that one? I'll wait a couple seconds in case people are still writing stuff down. And so, Jay, if you were doing this by hand, yeah, you would have to plug in the 2.38, and then you'd essentially have to do the top bound, bottom bound. Or, oh, why doesn't it let me share that one? This is where, if you have a calculator that can do so, you can punch that sucker in. So what did it end up being? Let me just type in 1 real quick. Boop, 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 boop. And of course, that wasn't the final answer. That was just the answer for the one piece. So you can do it in your calculator if you have a calculator that can do so. If not, you'll do it by hand by doing the antiderivative and then doing the top bound minus bottom bound that we did in 6.3. If you're putting it in your calculator. That's a good point, Juliana. So when you're doing the second one, so since it's 0 minus, put parentheses around the bottom function, or else you're not going to get the right answer. So if let me do this really quick, minus 7x squared plus 11x parenthesis. So I should get 5.05, which I do when I do that. But if you had forgotten those parentheses, and you just thought top bound minus bottom bound, top function minus bottom function without parentheses, then you would get negative 117, which is not right. Yeah. So make sure whenever you're doing, I would just suggest always putting the bottom function in parentheses, even if it's like a simple function, just to get used to it. Because if you don't have those parentheses there, then yeah, you're gonna get a wrong answer. Any more questions? And Jay, let me know if that didn't answer your question. Does anyone need to see more work for the by hand option? Anything like that? I'll give like 5 seconds before I scroll down to the next one. Good. Okay. All right. So we're going to come back to some ones like that in a second, but let's look at this kind of barely different question. So for the following, determine, that should say if, not of, if the integral from 0 to 5 of f of x dx would be positive, negative, or approximately 0. So this goes back to kind of the very first thing that we talked about on Wednesday. Maybe we even talked about it on Monday. Anyway, when we were starting these notes, the 5.3 notes, we found that any area below the x-axis turns out to be negative in a general integral. So if I'm looking at this first one, I have like this teeny tiny area on the very left that's above the x-axis. But then most of my area I'm going to get in this integral is going to be down here. So since the bulk of the area ends up below the x-axis, and in a general integral, any area is treated as negative, this integral would end up being negative. I don't know what the value is because I don't know the function, but since most of the area ends up below the x-axis, that will end up being a negative result. Well, let me just finish this and then I'll say that. In the second one, we have this kind of first piece of area above the x-axis, and then the second piece of area below the x-axis. Also, the area is always going from the function to the x-axis. If you're confused of how to form it, It's always between the function and the x-axis. So here we have some area above the x-axis and some area below the x-axis, but it looks like there's more area above the x-axis. So even though that area below the x-axis is going to be treated as negative and essentially take away from the area above, there's more area above, so this will end up being a positive result. Most likely. Again, we can't say for sure because we don't know the actual values, but it looks like it's probably going to end up being positive. And then this last one, we have some area above the x-axis and some area below the x-axis. Now, both of those areas seem to be approximately the same size. They look to be about the same shape and the same size. So if one of them is going to be treated as positive and the other one's going to be treated as negative, but they look to be the same amount of stuff, that's going to end up making this approximately 0. Because those are essentially going to cancel each other out. So I do want to clarify, just in case it's confusing. For general integrals, you just calculate it like we did in 6.2, 6.3, where you just find the antiderivative, plug in the bounds, call it a day. And when you're thinking about what that's actually telling you in terms of the function, if you say you're looking at the graph and you're looking at the area, in a general integral, area above the x-axis positive, area below the x-axis negative. The only time that we have to do this super long, crazy hoopla is when we're talking about total area or area between two functions. If you're just told to calculate an integral, just calculate the integral. That also means that there are some types of questions that I could ask you, and you'll actually see this on your exam review as well. Say I can give you a generic picture of a function and I say the area in this piece is 5 and the area in this piece is 3. What is, you know, the value of the integral from 0 to 5 of f of x dx? And you can actually calculate that now that you're actually given some values, because essentially that would end up being 5 minus 3. So the area would end up being 2 because the area above the x-axis is positive, the area below the x-axis is negative. So since I'm asked to calculate a generic integral, the 5 is positive and the 3 is negative. If you were asked what's the total area, that would be 8, because when you're finding the total area, you want to treat anything that's below the x-axis as positive. But in a general integral, above positive, below negative. You just don't mess with it. Questions concerned about that? It is that easy. I swear. For a question like that, if you're just given the values in the little area pieces, that's it. If you're asked to find the general integral, you just add the areas above the x-axis and subtract off the areas below the x-axis. And you call it a day. That's it. Promise. All right. So now let's go back to the super long hoopla. So we've got 2 more questions of the super long hoopla, which is probably going to take the rest of class. But notice here, it's no longer phrased as a total area question, and we're actually given 2 different equations, and we want to find the area between them. So it's the same exact process. It's just that now that one of them is not y equals 0, so it's going to be a little more work. The process is the same though. So we have 2 functions that we're working with. So the first thing we have to do is find where they intersect. Now this one is a little too hard to do algebraically. Like, I don't even really know how to do it algebraically. So we're going to do that on our calculator, and I can show you how if you don't know. In terms of things that you'll see on your exam, they will always be able to do algebraically. You might have to use the quadratic formula, but it'll be able to be done algebraically. But we want to set these 2 equations equal to each other. And now we need to break out a calculator because I don't know how to do that in my head. So if you have a TI-83 or 84, what you would do here, and if you don't, if you want to know, you can Google it. But again, all of the ones that I'll ask you can do by algebra. But you go to the y equals key. So notice at the very bottom of, oh, I didn't share the calculator screen. So notice at the very bottom, it tells you what keys I pressed. So if you missed what I pressed at the very bottom of the screen, it tells you what buttons I pressed. So I pressed the y = key, and if there was something in there, you got to clear it. And now we're going to essentially put both of those functions in separately. So our one function was 4x minus x squared. Then I'm going to go down to the next one and do my 1/2. I'm going to put the 1/2 in parentheses just to make sure it reads it right. X raised to the, let's go ahead and put the 3/2 in parentheses. If you have a newer calculator, it doesn't matter as much, but with the older calculators, definitely put that 3/2 in parentheses. So you put both of those in there, and then you hit the graph button. Well, I guess you don't have to hit the graph button. You don't have to watch it be graphed, but let's go ahead and watch it be graphed. Come on. There we go. Okay, now I can't switch back to the problem. Well, I could, but it'll take too much. Anyway, so in the problem, it says for x is greater than or equal to 0. So we're actually not given an endpoint. So when we're not given an endpoint, it's going to end up being wherever they intersect. So the endpoint is going to end up being whatever the heck this value is right here. So let's go ahead and find that. So to find that, what you're going to hit, you're going to hit second, and you're going to hit the trace button. And then you can either scroll down to number 5, or you can just punch in 5 on the keyboard. If the only two functions you have in the y = key are the two functions you need, then you can just press enter, enter. Otherwise, you'll have to use the up and down arrows to make sure you select the right ones, but we can just press enter, enter if those are just the two functions that we have in the y = key. And then notice at the bottom it says guess. So then you're going to use the right arrow or left arrow, depending on which direction you need to go, and move that little blinky over until approximately where they intersect. You don't have to get it perfect, but you have to get it close enough, and then you hit enter. And it tells you. Hooray! So they intersect at approximately 3.1, let's say 3.12. So you plug both of the functions into the y = key, you hit second trace to get the calc, hit number 5 for intersect, enter, enter, scroll over until approximately where they intersect, enter. So we used our handy dandy calculator to tell us that these intersect at approximately x = 3.12. So we're done that step. Hooray! I'm not going to write down, well, no. So I used to write down that little split step, but like it doesn't really, this thing right here, it doesn't really do anything for our lives. So I'm just going to kind of jump to the top bottom piece. That split step doesn't really do anything but take up space. Now notice the interval that we're given is x is greater than or equal to 0. So we're essentially starting at 0, and we're going to make it stop where they intersect. So if it doesn't give you a full interval, like a closed one with 2 endpoints, you're going to take whatever value that they intersect at, and that's what you're going to use to close it. So now we need to figure out which function is on top of the other. Well, we have the graphs. We can go back to that in a second. But if we wanted to do this algebraically, you would pick a number. So I don't know, let's pick 1. You would plug that value into both functions. So if you plug that into f, we'll get 3. And if we plug it in to this one, if we plug in 1 there, we'll get 1/2. So 3 is on top here. And really quickly, that also makes sense looking at the graph. On my screen, the blue curve is above the red curve, and the blue curve was the 4x minus x squared. So we know our top function. At this point, we're already ready to find the integral, sorry, goodness gracious. So we're essentially on the integral from 0 to 3.12. Now here's especially where you need to be careful with top minus bottom and putting parentheses. So our top function was the 4x minus x squared. So it'll be our top function, so 4x minus x squared minus, and let's just go ahead and start putting all of our bottom functions in parentheses. We don't technically need it here, but let's just be safe and put it there anyway. Of course, you can type this into your calculator. I'm going to write down the antiderivative in case anyone has to do these by hand, but I'm not going to write down the top bound minus bottom bound step unless someone asks me to do so. But the antiderivative would be 2x squared minus 1/3 x cubed. And oh, I actually need to think about this one. That would be 1/2 x to the, so 3 halves plus 1. 5 halves divided by 5 halves. That'll give me 1/2 times 2/5. So those are going to cancel each other out. So we'll get 1/5 x to the 5 halves plus e from 0 to 3.12. So then you'd plug in 3.12 and subtract what you get off when you plug in 0. And if you punch this into your calculator as well, either way you should get 5.906 approximately. Okay, Jay, so we're always working on intervals, right? So the x equals 1, so I'm working on the interval 0 to 3.12. So I have to pick a number in 0 to 3.12. So I chose x equals 1. You can pick absolutely any number in that interval. Essentially, because what we're trying to do is we're trying to see which one's higher than the other. We're trying to compare y values. So I need to pick an x value in that interval to plug into both functions. So I just chose x equals 1 because I felt like it. It seemed like a nice number to use. It's very similar to when we were doing those number lines with the first derivative and your test point. Same kind of idea here is we need to have a test point to figure out which one's on top of the other. Any more questions about that one? So same exact process as the total area questions. It's just that we're not using y equals 0. Now we're actually given two functions. So yeah, in terms of these kinds of questions on the exam, essentially all of the work I'm expecting is I'm expecting you to show me where they intersect. I'm expecting you to tell me somehow that you found the top versus bottom. So if you don't do the algebra, so on an exam, if you don't use algebra, I literally want you to write down used graph. Or you can either draw the graph, that also works. But I need you to at least tell me that you did something to find which one was on top of the other. And my instructions usually say that, but anyway. So I need to see the work for the intersection, top versus bottom, and then what I need is I need the setup. And then once you have the setup, if you just want to type it into your calculator and get the answer, that's fine. So you don't need to do any of the work for the integral for these types of questions. Again, you will have to do work for integrals for just basic integrals. I'll say, here's an integral, calculate it. But in terms of these area functions, you just need to set it up and then tell me what the answer is. So let me clean that up a little bit. Any more questions about that one? So when I write the answers to the review guide, I'll try to be super specific. When I do the answers to these questions, I'll probably do the work for the integral, but I'll try to make like a side note of you don't need this work, so that you can kind of get an idea of what I would be going for. All right. Well, if we're good on that one, then we've got one more to go over. Sorry. Yeah, so essentially, since we're always working with two functions here, one of the functions is just sometimes 0. It's always going, well, ooh, careful. Sorry. Jay, it's always top minus bottom. So that's why we have to do this work here to figure out which one's on top of the other. So it's not always going to be f minus g if you're just naming the functions. Sometimes it'll be g minus f because sometimes g of x actually ends up on top. So it depends on which function is on top of the other, but the integrals are always the top function minus the bottom function. So you got the 3.1.2. Yeah, So my calculator told me the 3.12. That's where we plugged them both into the y equals key, used that intersect piece of the calculator to get me that. So that was when I was doing the second trace intersect. So yeah, that's where I got the 3.12 from. And again, all of the ones that I ask you to do on the exam would be able to be done via algebra. You wouldn't have to. Yeah, I mean, you could put them in your calculator if you wanted to, but. Okay. If there are no more questions, we'll do this last one, which, yeah, will pretty much take us up till the end of class. So this last one, now that I have that stupid little thing on the screen, there we go. So find the area enclosed by the square root of x and x squared. And so now we're actually given an interval, so we don't need to worry about closing it, but we still do need to figure out where they intersect. So we need to find where the square root of x equals x squared. Now we need to be kind of careful with this one because this was one that a lot of people will get wrong algebraically. So we actually can do this algebraically. So what I'm going to want to do is I'm actually going to want to get rid of that square root because that's like the harder thing to work with. I can kind of work with a squared, but I don't really want to work with a square root. So how do I get rid of a square root? I can get rid of a square root if I square it. But if I square one side, I have to square the other. So we'll get x equals x to the fourth. Now, here's where a lot of people will make a mistake. And technically you can do this, but you need to consider something. So a lot of times people would say, oh, well, divide by x. Sure, but you're actually going to lose an answer if you do that. And I'll explain that a little more in a minute. So try to avoid dividing by variables because you actually end up kind of losing an answer if you don't think about it correctly. So I'll talk about that a bit more in a second, but what you want to do instead, let me leave a little bit of space for when I want to talk about it. But what you want to do instead is you want to bring all of the x's onto the same side. So instead of dividing by an x, let's go ahead and subtract that x over to the other side. And then I'm going to pull it out of both terms. So I get x cubed minus 1. So we'll get either x equals 0 or x cubed minus 1 equals 0. So x equals 0 and x equals 1. So here we don't need plus minus because it's an odd power. You'll need a plus minus when it's an even power. Now, oh, hold on a second before I talk about that. Now, the reason you want to be very careful with dividing by a variable, just in case any of you are like, why the heck couldn't I divided by x? Let me zoom in a little bit. So if we divided by x here, we would have gotten, nope, we would have gotten 1 equals x cubed, so x equals 1. So we would have gotten x equals 1, which was an answer the other way, but another answer was x equals 0, and I didn't get that this way. And the reason that happens is when you divide by a number, remember you can't divide by 0. That makes the world explode and me cry at night, so don't do it. So when you divide by x, you have to assume that x is not 0, or else you can't actually do the division. So even though we wanted to say that they intersect at 0, once you divide by that variable, you essentially get rid of that option, unless you think you remind yourself that it could have been 0 and then think about it. But anyway, so that's why you should always avoid dividing by variables if you can. Instead, what you want to do is you want to collect all of the variables onto the same side of the equation, and then if you can factor them out, do it that way. Anyway, what is that little, what is that? Get out of here. So we have 0 and 1 as the 2 points where they intersect. So the 0 we don't really need to care about, which might have, then would have saved your butt if you had accidentally divided by the x. But we don't really need to care about it because it's already an endpoint. But x equals 1 is inside of 0 to 4, so we're going to need to split this up You're going to need to talk about 0 to 1 and then 1 to 4. So we need to figure out which function is on top of the other so that we can figure out our intervals. Goodness. So once again, I'll do it algebraically. I'll do it both ways. So pick a number between 0 and 1. Any number you want, I'm going to pick 1/2. Plug it into both functions. I'm going to write it like this now. So if I plug it into a square root of x, I'm going to get 0.707 approximately. And then 0.25 if I square it. Which one of those two numbers is larger? Well, they're both pretty close to each other, but the 0.707 is larger. So that means f of x is going to be our top function for our first integral. And then pick a number between 1 and 4. I'm going to pick 2. You can pick whatever number floats your boat. So whenever I'm writing, whenever I'm doing the f, that's the square root of x. And whenever I'm doing the g, that's the x squared. Whoops, let me box the whole thing. So since they were given names, I'm using their names this time around. Sorry about that. But I'm using square root of x and x squared. So here, I'll write this out a bit more fully. So the square root of 2 gives me approximately 1.414. And 2 squared gives me 4. No, you're fine. So the top function in that one is going to be 4. If we were to look at the graph, we would have, so x squared. So, nope. And then this looks like, and then so they're going to intersect at 1. So essentially, g of x is on top for the, what? Oh, did I draw that wrong? Oh wait, did I mix up in my brain? No, I didn't. I think I'm just being stupid. Oh yeah, no, I'm being stupid. I'm sorry. I thought f of x. Oh, that's because I did label them wrong. Okay, that's why. I am really stupid. This is g. This is f. Yep. Thanks. That was me being dumb. I drew them right. I just labeled them wrong. So g of x was x squared, and f of x was square root of x. So we do end up matching what we found algebraically. Sorry about that. So the square root of x ends up being on top in that first piece, and then the squared x squared ends up being the top in the second piece, graphically as well. So the two integrals we're calculating are from 0 to 1, and then from 1 to 4. So top function minus bottom function. So the top function in the first one was f of x, so it would be the square root of x minus x squared. And then for the second one, g of x ended up on top, so it was x squared minus square root of x. And now my little stupid tangent took too much time. If you were to calculate these, you'd get 1/3 plus, now I hate writing mixed numbers, but here I go, I wrote one. We get 16.6 repeating, essentially. The antiderivatives, if you're curious, would be x to the 3/2, 2/3 in the front, minus 1/3 x cubed from 0 to 1, dropping my c just for the sake of space, because they always get canceled out in those types of calculations anyway. So there's our antiderivative, 2 pieces. We're officially out of time, so if you need to leave, feel free to pop out. But if you have any questions, round. And so this is the end of 5-3. On Monday, what we're going to do is I'm going to start by asking questions to see if anyone has any questions about the exam. We can go over topics. We can go over questions from the review, anything like that. If there are no questions, I'm going to go on to 5-4 just for the sake of time. I'm not saying that we need to go on to 5-4. If there's questions for the entire class, that's perfectly fine. But just know that if there aren't questions, we're going to move on. Not to anything that will be included on your exam. 5-4 is not included on your exam. But we would move forward if there are no questions or if questions don't take the entire time. But otherwise, the review's up. Answers will be up sometime this weekend. Exam's on Wednesday. Expect you to take it in person. Let me know if that's a problem. Have a great weekend. See you on Monday.
I have a quick question.
Yeah.
Are our quizzes, our last quizzes, Unit 10, are those graded yet? Or because I have a little like explanation mark on next to my grade, and I clicked on it, and it says that like 2 of them are 0 out of 8, and the rest needs to be graded. So I'm just confused if I got 2 of those problems wrong.
Oh, so quiz 10 is the one we just took on Wednesday. Those aren't fully graded yet. No. So I still need to go through and grade those by hand.
I understand. I clicked on the little explanation mark though, and it said 2 of them were 0 out of 8. Does that mean I got both of those wrong, and then the other 2 be graded?
So Blackboard tries to grade them, but does a trash job at it.
Okay.
So I'm looking at it, and from what I see, they look. Oh, trying to read math on a computer. They look great, and it's just the notation. So I tried to put. I have 4 different answers for Blackboard to choose from.
Yeah.
But there's so many different ways you can type it in that I can't think of them all. So it thought you were wrong, but they look right. So that's why I go back and grade them by hand. So you should be fine on those.
Perfect. Thank you so much. I appreciate it. I was just worried. All right. Thank you. Have a good weekend.
You too.